Okay. Slope. So let's say we're given 2 points, x1 comma y1, and we have x2 comma y2. I wouldn't be surprised if some of you remembered the slope formula. Rise over run, okay, you're right. How do we interpret that in terms of x1, y1, x2, y2? Okay, good. Most of you can remember rise over run, right? That's not too hard to remember. That will actually help you remember the formula. Rise means a change vertically, right? That's rise. So which ordinate, the x or the y, represents a vertical change? So it has to be y on top because it's rise over run. Run represents a horizontal change. Which ordinate represents horizontal change? X. So it's y on top, x is on the bottom. Rise over run. So it's y2 minus y1 divided by x2 minus x1. So the slope, usually denoted by the letter m, is equal to y2 minus y1, x2 minus x1. Here's a little symbol that you're going to see a lot of. It's called delta. Delta y over delta x. Delta means change. It's the change in y divided by the change in x. And this is going to dominate like the first 3 or 4 months of calculus, how things change. So we're going to see a lot of this idea of delta. Okay? True or false? All linear functions have a slope.
False.
Well, let me rephrase that. I'm going to take out the word function because that kind of changes things. Any linear equation has a slope. It's true except for one case, and what is that? When the line is vertical, there is no slope. That's undefined. So if it's a linear function, then it's going to have a slope because a function would exclude the vertical line. But anyway, what's the slope of a horizontal line? 0. The slope of a vertical line is undefined. The slope of just a normal line is going to have to be found using the formula here. Okay. Do we really need to practice finding slope between 2 points? Can we skip that? Okay. Just as long as you know the formula, I think you're going to be okay. So let's get into some actual problems here. So here's equation, or example 1. Find the equation. Of the line that has a slope of 3 passes through the point 1 comma negative 2. Now, I'll show you 2 ways to do this, and I think they're both equally easy, if that even is, anyway. I don't think one's more difficult than the other. Here's what the book would suggest. You recognize this formula, yes? Yes. That's the slope formula. Now, what if we multiplied both sides by x2 minus x1? What's that going to do? Cancels that, right? And then we end up with the equation y2 minus y1 equals m times x2 minus x1. Do you recognize this at all? Does anybody recognize this? Eventually we could lead it to that, but you might remember it more like this. big Y minus Y1 equals M times quantity X minus X1. You've seen this before from Algebra 1?
Yeah.
It's the point-slope form of a line.
Okay, and sometimes students have a hard time remembering just the straight up formula, but remember maybe where it came from. Where did this point-slope formula even come from? All it came from is the slope formula, right? Just manipulating the slope formula. So we can use the point slope.
I tend not to use it. Not that it's hard to remember, it's just not the way I would do it. But anyway, we can use this point slope formula because in order to use point slope formula, what two things do you have to know? A point and a slope, both of which we have been given. So plug in the slope, which is 3, and then plug in the known values for x1 and y1. So that's going to give us the equation y plus 2 is equal to 3 times the quantity x minus 1. Why did I change it to y plus 2?
Y minus negative 2 is the same as y plus 2. You follow?
Yeah.
Okay, now we need to change this into
Slope-intercept form. This is point-slope form. We need slope-intercept. What's the difference? Slope-intercept form is y equals mx plus b, right? So all we got to do is distribute the 3, and then subtract the 2. So y equals 3x minus 5. So there's the equation of the line that has a slope of 3 and passes through the point. This way works. It's a great way, especially if you can remember that point slope formula. It's a great quick way to do it. Here's option B for those that are interested. So the slope is still 3 and the point is still 1 comma negative 2. We're supposed to come up with this form of the equation, true or false? Y equals mx plus b, right? Do we know the slope? Do we know b?
No.
But do we know an x and a y?
True.
So plug all the known values in. Y is negative 2, m is 3, x is 1. That'll help us solve for b. Correct?
Correct.
If you subtract the 3 over, then b equals negative 5. So that tells us the equation is y equals 3x minus 5. They are different methods. It leads to the same result.
Okay, so whichever way you want to use
it. Doesn't matter. If you use point slope form or if you use that method in red where you just lead straight to the slope intercept form. Same thing. All right. Let's go on. Example 2. Alright, these are kind of contrived problems, meaning they're trying really hard to make it seem like it's real world stuff. It is what it is. We are going to see a lot of real world data, but with such simple subjects like slope and things like that, it's kind of hard to find a lot of real world application. But anyway, here we go. In a tournament, in a water skiing. What? A water ski jumping tournament? Is that even a thing?
Oh, it's huge in Italy.
In a water ski jumping tournament, the ramp. I guess I have seen some of these. You guys see these ramps out on the lake and you jump out? I guess they do have these. The ramp rises to a height of 6 feet. is 21 feet long. What are they even asking here? This is the stupidest question I've ever seen. We're skipping. All they ask for is the slope of the ramp. All right, moving on. What's the slope of the ramp?
6.
What the crap are they doing this kind of a problem in a calculus textbook?
They're trying so hard, they just skipped over what they were supposed to.
It's 6 over 21, which is
Some fraction.
reduce the fraction.
3 over 7. No, it's not 2 sevenths.
2 sevenths.
Oh shoot, 2 sevenths.
Man, that was retarded. Okay, let's find a harder one here. All right, here's a harder one. That's a bad one. Example 3. Find the equation of the line that passes through the point 2, negative 1 and is perpendicular to 2x minus 3y equals 5. Now, I'm sure you've heard the word perpendicular before. Most of you hopefully remember what it means, but for those that are a little fuzzy, perpendicular lines, 90 degrees, they cross at 90 degrees, right? So in terms of slope, do perpendicular lines have the same slope? No, obviously not. What is the relationship in slope of perpendicular lines? They're opposite reciprocals. So if one has a slope of 1/2, the other one has a slope of negative 2 over 1. They're opposite reciprocals. So, first thing we need the slope of this line. If we don't have the slope of the line, we can't come up with a slope that's perpendicular to it. So you guys do that. Go ahead, figure it out. I don't need to show you how. We need the slope of that line. You should be transforming the equation. The slope-intercept form. I don't know. Are we getting a slope of 2/3?
Yes, sir.
Okay. Is that the slope we use?
No.
No. If I wanted a parallel line, then yes. I don't want a parallel line. I want a perpendicular line. So, like, tell me your name again. Olivia said we need slopes that are opposite reciprocals. Reciprocal means flip the fraction. Opposite means change the sign. So the slope we're going to use is negative 3/2. Negative 3/2. Okay? So to write the equation in slope-intercept form, y equals mx plus b, use the known values. We know a point and we know a slope now, so y equals negative 1, slope is negative 3/2, x is 2, plus b, fractions are just normal numbers.
In calculus, fractions are normal numbers. They're no more difficult than any other number, right? Fractions are just numbers. They deserve respect.
Okay. Negative 3/2 times 2. That's pretty simple. Negative 3/2 times 2. It's negative 3. So if you add 3 to the other side, you get 2. So the b value is equal to 2. The equation becomes y equals negative 3/2 x plus 2. The only difference, had I said I wanted a parallel line,
The only difference would have been you would have used the exact same slope 2/3 rather than the opposite reciprocal.
okay? Questions so far? Pretty easy, yes? Okay, just to mention, I talked about this at the beginning, but just so we have it on the recording. Vertical lines, the slope is undefined. What's the equation of a vertical line? X equals something. You might want to write this down. If it's a vertical line, it's x equals whatever the x-intercept is. It's x equals that number. If it's a horizontal line with a slope of 0, then it's just y equals a constant, like y equals 10 or y equals negative 2. That's a horizontal line. Okay. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Okay. I did assign a few problems from P3, so let's cover those real quick. This is still just one lesson, one unit, or one lesson here. So this is from P3. This is the last preparation section that we're doing. Starting on Thursday, we get into actual calculus. I know, right? Yeah. There's two things from P3 I wanted to quickly cover. Domain. And the second thing was, well, there's actually three things, sorry. Composing functions. And the third thing is even or odd. Does that sound familiar? Even or odd functions, that's a pre-calc topic. Okay. And all of this should be reviewed, but I just want to make sure that we can do this here. So let's start with domain. Finding domain of specific functions. Domain meaning, what is domain? What's the domain of a function? The all possible x values. Okay, or the inputs. The range would be the set of all outputs. So, oh, what are some easy ones here? All right, here's an easy one. Find the domain. Here's example 4. Well, okay, maybe not so easy. I don't know. You be the judge. Find the domain of that awesome function right there. Now, we're going to talk about this together, and it's good that you're thinking about it, but if you're like, oh, what? Don't worry, we're going to talk about it. What two issues are we dealing with here? There's two potential problems I can see. It's a square root, and it's on the bottom of a fraction. It's in the denominator of a fraction. Why are both of those problems? Well, you can't divide by 0, and you can't square it to negative value. So, what do you suggest? We could rearrange this. That would work. You're talking about rationalizing the denominator. We could if they wanted us to simplify this, but in terms of finding the domain, we don't necessarily need to. So let's not do that. Would you guys agree with this statement, yes or no? Look at it very carefully for like 10 seconds before you blurt out an answer.
What do you think? Is that true or is that false? Give you like 5 more seconds to think. Think really hard.
So, true, raise your hand. True. False, raise your hand. Undecided. Undecided. Okay. If we're saying that this is true, then wouldn't this also be true? If you're claiming that this is true, then this has to be true. Is it possible for x to equal 1? Well, you can plug a 1 in here, and 1 minus 1 is 0, and you can square root 0, right? That's not a problem. But then what is the problem? Then you're dividing by 0, and you're running into a big problem. So this is mostly right. There's just one problem. You got to get rid of the or equal to. X has to be strictly greater than 1. So the domain in interval notation is parenthesis 1 to infinity. No. If it was just a square root, and that's it, then the way that you find the domain of a radical function is you take the expression inside the square root, and you normally do set it greater than or equal to 0. But since it was on the bottom of a fraction, it can't actually equal 0, because that would mean divide by 0. Does that make sense? So, yeah, you take whatever's inside the square root, and it has to be greater than or equal to 0. Otherwise, it's undefined.
So when you're finding the domain of a function, you just like look at the function, and you should be able to know from it what the domain is.
Well, sometimes. Here's a question. What if I put a quadratic function up there? You guys understand what quadratic is?
What is a quadratic function? Makes a parabola, right? There aren't any holes, there aren't any gaps. What's the domain of a quadratic function? Any quadratic function. All real numbers. What if I put a linear function up here, like y equals mx plus b? What's the domain of any linear function? All real numbers. Certain functions are going to give you trouble. Radical functions like the square root give you trouble. Rational functions like this one where it's the top and the bottom, those give you some trouble. But sometimes you can just look at an equation and know that it's all real numbers if it's linear, if it's quadratic, if it's absolute value. Do you remember what those look like? They're V-shaped. Those have domains that are all real numbers. Here's another one. This one gets a bit tricky, but it's going to be fun. And by fun, I mean fun. Bracket means included, so if this had been greater than or equal to, then you would put a bracket around it. Does that answer your question? Parenthesis means not included. Bracket means included. Alright, good luck on this bad boy. Yo.
Are you recording this?
I am.
Because I gotta get this stuff.
Okay. Yep. It'll be posted. Ooh, me likey.
Huh. You're gonna try to challenge us.
Me likey.
Or not.
It worked for me.
This is not a quadratic function. I know there's an x squared there, but it's not a quadratic function. This would not be a parabola. This is a radical function. If you were listening carefully a few moments ago, I kind of explained how to find the domain of a radical function. Whatever the expression is underneath the square root, that expression has to be greater than or equal to 0. Okay? Just everybody look at the screen for just a second. Put your pencils down. I want to explain something here. If I erase this and just put a big giant capital A, in order to square root capital A, doesn't capital A have to be greater than or equal to 0? In order to square it. Otherwise it's undefined. So regardless of the expression, it doesn't matter what's under here. In order to square root it, it has to be greater than or equal to 0. So our expression, x squared minus 3x plus 2, in order for this to be defined, x squared minus 3x plus 2 must be greater than or equal to 0. Now,
This is a quadratic inequality that I don't know when it was taught. Some of you it might have been in Algebra 2. Some of you it might have been in pre-calculus. Some of you might not have been. I don't know. A quadratic inequality. Does this look familiar at all?
It's a lot like solving a quadratic equation. If this were a quadratic equation, how would we solve it? Either by factoring, which for quadratic inequalities, that's usually going to be the case. If it doesn't factor, you use the quadratic formula. But anyway, I believe this does factor.
It does.
X minus 2, x minus 1, right? Now, depending on who your instructor was when this was taught, it may have been explained a couple of different ways. This is how I teach it. What would the zeros be from this function? 1 and 2. So on a number line, a real number line, you're going to place points on the zeros, 1 and 2. Just curious, does this look familiar to anybody where you put like pluses and minuses above the number line? Does that method sound familiar to anybody? That's what we're heading here. Let's test a point on the left side of this 0. So I'm going to use 0 as my test point. If I plug in a 0 for both x's, I'm going to get a -2 and a -1, and I'm going to multiply that, right? Is that a plus or a minus? That's positive, right? Because negative times a negative is a positive, so that's a positive region. I'm going to choose a test point now in this area of the number line. I'm going to choose 3 as a test point. 3 minus 2 is 1. 3 minus 1 is 2. 1 times 2 is positive, so that's a positive region. And just to be sure, I mean, I kind of have an idea of what's going to happen here, but just to be sure, we do need to test a point in the middle of these two numbers. Unfortunately, it's going to have to be a decimal, but really all that matters is the plus or minus. 1.5 minus 2, is that a plus or a minus? 1.5 minus 2. That's a minus, right? What about 1.5 minus 1? That's a plus. And then a negative times a positive is a negative. So there's a negative region in between. Now you got to decide which region do you want. Do you want the positive regions or the minus region?
How do we know we want the positive? It has to be greater than 0. So I want this region including negative infinity to 1, and I want the region including 2.
To infinity. So the domain here is going to be bracket, or sorry, parenthesis, negative infinity to 1 bracket, union, bracket 2 to infinity. That wasn't so bad, was it? Okay. You got to get crack-a-lacking here. Let's talk about composing. You've done a lot of this. All you have to do, I think, is see it once, and then the light bulb's going to go off. Composing functions. Let's say that f of x is equal to 3 divided by x, and g of x is equal to x squared minus 1. Find. Does this look familiar? That's called composing a function, or finding the composition of two functions. This is only one of the possible notations. There is another way to write this. What does this really mean? This means f of g of x. That's what it really means. F of g of x. Well, what the heck does that mean? That means that the g function goes inside the f function anywhere that you see an input. So for the f function, here's the input. So f of g of x is going to become 3, and instead of dividing it by x, it becomes x squared minus 1. That would be composite function. Okay. And if you thought you were done, think again. What's the domain of the composition? It's all real numbers except for two. There's two numbers that don't work. Positive one doesn't work. Negative one doesn't work. How come? It would make it 0 on the bottom. Okay? If you're having trouble seeing that, check this out. X squared minus 1 is really just the product x plus 1, x minus 1. It's just the difference of squares. So x can't be positive 1, x can't be negative 1. Now, if you want to represent the domain in interval notation, you can. Here's how you'd have to do it, though. You ready? If x cannot equal 1 and x cannot equal negative 1, then in interval notation, that's going to be negative infinity to negative 1, union negative 1 to 1, union 1 to infinity.
That's all it works.
Why does it have to be that? Well, this means it's every number except for what two numbers? Negative 1 and 1. That would be using interval notation. There's another notation that you might have been introduced to in pre-calc called set builder. You could say that the domain is all x's such that, does this look familiar? X does not equal plus or minus 1. That's called set builder notation. So, yeah.
I have a question. With interval notation, how come we're using parentheses in this one instead of
Brackets means included. And we can't include negative 1 or 1 because that would make that undefined. Does that answer your question?
Yeah.
Yeah. Parentheses means not included. I know we're traveling at light speed. Is that enough of a refresher on composing functions? We good there? Okay, the last thing is even versus odd. We've actually already covered this last time. I just didn't say. Even versus odd functions. All you really need to know is the definition. An even function has y-axis symmetry. An even function has y-axis symmetry. For example, how do we know that has y-axis symmetry? Think back to last time. What did we learn to do to prove that that has y-axis symmetry? You got to see what happens to f of negative x. Well, if you plug in a negative x, what's negative x raised to the 4th power? It's just x, so that's x to the 4. And then negative x raised to the 2nd power is just x, so nothing changed. We end up with the same thing we started with. That's indicative of an even function which is symmetric to the y-axis. Clear on that? Okay. Odd functions have origin symmetry. So, for example, I don't know, f of x equals x to the 3rd plus x. This will be an odd function because if we test what happens to f of negative x, if you replace all the x's with negative x, you end up with the exact opposite. You end up with the exact opposite of what you started with, negative f of x. That's an odd function. Wow, that was a lot of stuff. Are your brains full?
Brains are full. We need to upgrade your hard drive, right?
To have more space.